Hello, in this final video I will perform a security analysis of 4 critical vulnerabilities found in Python applications. For each case, I will demonstrate the exploit and present the secure implementation. Okay, so let's begin with Activity4Entrega2SeguridadEBC. So basically, in this script, the database IP address is hard-coded as a static string, as you can see here. So while an IP address might seem less critical than a password, hard-coding infrastructure configuration is a bad practice. If this code is pushed to a public repository like GitHub, our network topology is exposed. So furthermore, changing the IP will require modifying the source code and redeploying the application. So let's gonna test it. So if we execute this script, as you can see here, the script confirms that the configuration is exposed. And to avoid that, we have this secure code that I'm gonna explain now, and this secure implementation uses the OS library. So we use the OS environ get to fetch the database IP from the operating system environment. This effectively decouples the configuration from the application logic. So let's go back here to the terminal, and we have to execute this code, this command that we have here. We execute it, and now we have to execute our script. So by running the script manually in this session, the application dynamically retrieve the correct IP address, so the secret is no longer in the file. As you can see here, we have the IP that we have configured on the environment variables. Next, we have the Activity4Entrega2SeguridadEBC. So here, let's gonna open. Here, the developer used the standard random library to generate a security token. The issue here is mathematical. Python random uses the Mersenne-Twister algorithm. It's a pseudo-random generator, so it is deterministic, meaning that if an attacker can deduce the internal state of the seed, they can predict every future token generated by this server. So let's gonna execute the code to test it. We have to access to the folder. 1 second. Now we can execute the code. So this output looks random to a human, but is predictable. So we have to try to make it more secure. Now we're gonna look at the secure solution just to see that this one is better than the other one. So to fix this, we must use the secrets module introduced in Python. So this library is designed for cryptography. It bypasses the pseudo-random generator and pulls entropy directly from the operating system kernel, ensuring the values are truly unpredictable. So let's test it. As you can see here, this is more secure than the other one that we have generated before. Okay, now moving to CWE20. Let's gonna open the files. Okay, so Input validation is critical. Here the code attempts to sanitize user input using a blacklist approach. It specifically tries to remove the script, this one over here, tag. However, the blacklist are weak, so look at my payload. So this one, I have nested a tag inside another. So let's gonna execute the script to see how it works. So when the code executes the replace function, it removes the inner tag, but look at the output. The remaining characters merge to reconstruct the malicious tag. So the filter is completely bypassed. So now let's gonna open the secure code, and here we have the robust solution that is a whitelist that just says regular expressions that we define exactly what is allowed. What we allow is only alphanumeric characters, as you can see here. So anything that is not a letter or a number is stripped out. Let's gonna test it. So the secure output shows that the attack is neutralized. Finally, we have the CWE 134. So let's gonna open it. In Python, the format method, this one, is powerful but dangerous if it's used with untrusted input. It allows object introspection. So my payload instructs the Python interpreter to access the object's constructor, then the global scope, and finally read the secret key. So let's gonna test it. Let's gonna execute it. As you can see, I have successfully leaked the server secret key. So basically, to prevent this, we replace the format with the string template class. So templates are designed to be simple. They treat user input strictly as text data, forbidding any code evaluation or internal access. So let's execute the code. So when we execute the code, the attack fails and the confidentiality of the system is maintained. In conclusion, secure coding requires using environment variables for configuration, cryptographic libraries for randomness, and whitelist validation for inputs. This concludes the audit, and thank you very much.